time to get these things on the road. So my estimate because it's basically funding what he's asking, my estimate is that we will secure our required funding. If I'm optimistic, I would say in the next 6 weeks. If I'm more realistic, I would say we can do that before the end of the year. So then 1 year later we can present a much more detailed version of Mars One's plan.
All right, and then just one more of his many questions. He says, needed on Mars in addition to mission return, which I guess in your mission plan there's not, but needed, I think that is pertinent, is construction equipment, mining capability, transportation means, repair capacities, facilities for the production of food on a sustainable basis using Mars resources. This requires new development and long-term testing on Earth and in space. Therefore, what are the plans of Mars One to develop and test a sustainable and self-sufficient infrastructure on Mars, providing Martians with acceptable conditions? In other words, how are you going to test all this ancillary equipment on Mars in advance of the crew?
So that is where we're very fortunate that Mars is actually a planet and not space. So Mars does have gravity, and the simulation outpost is a crucial part of our plan to start implementing and testing technical solutions. But everything will be step by step. So for example, it's our goal to start growing plants on Mars as soon as possible. And in this study it was not taken into account by Paragon yet, but we're because you need to develop the base without plants, because there's no humans yet to grow your plants, and because you always need a fallback solution in case for whatever reasons your plants are not growing. But growing plants is crucial for psychology, for sustainability of the funding of the mission, and we can test that with high fidelity here on Earth. But it doesn't have to be immediately with completely closed recycling or with Martian resources. You might, for example, take all the nutrients from the plants from Earth, which is a very small percentage of the total plant. Maybe you add the nitrogen from Mars because you have it there. It's relatively easy to produce what's the fertilizer. But you can keep adding Earth sent nutrients for your plants for a couple of years. That's acceptable in the mass budgets. But at some point in time, of course, can someone switch the button again, please? At some point in time, you do want these technologies, but they can be gradually developed over time. And as I said, what helps immensely is that will have a simulation outpost here on Earth where we can test the systems in a relatively high fidelity environment, namely a gravity environment.
Does the MIT team wish to take a couple of minutes to respond to Bas's most recent comment?
Yeah. So regarding the first question, in June of this year on Blue Work TV, you said you had executed a detailed technical feasibility analysis. So my question is, what is that analysis for the mission? And if the question is, when will you present the analysis, and you've stated that you have one, when will that one be presented?
There's TV and there's science conferences. As the CEO of the company, I always have to balance between how I phrase things. And our initial study has been a good investigation of the possibilities of sending humans to Mars, but not what NASA would call a detailed feasibility report. But our investors do. And when I show what we have done to our investors, that's what they would name it if I didn't write the name on it myself. So it's a matter of perception. For an aerospace engineer, there's very strict. They're right here actually on Barry's slide. there's a very strict timeline in when you call it a detailed design. That's not something that investors use. This timeline is not something that investors use. Investors have a completely different understanding when you say that word. And Bloomberg is not the kind of channel that scientists watch. It's the kind of channel that investors watch. So there I'm talking to an investor audience.
I'd like to address some of the comments that you made earlier. So you asked us, when Kennedy announced Apollo, did you have a plan? So we didn't have a plan at that time, but people had been doing serious technical studies for a long time. Within a year, 1962, the lunar orbit rendezvous decision was made. So a year after the plan was announced. So Mars 1 has been around since 2011. So, and it's 4 years, 3 years, 4 years, sorry, later. We still don't have a technical plan. So that's my first point.
NASA has been promising us a manned mission to Mars in 20 years, for 45 years now. So I think we still have a couple of years to go before we're behind on that schedule.
So, I'd like to point out that bashing NASA does not prove the feasibility of Mars 1.
Okay. I'll reiterate the finding of our study that one-way missions to Mars with increasing crews grows unsustainably over time, and then the cost grows unsustainably over time accordingly. So the comment was, you can delay your missions for another synodic period, but we've done analyses on that, and that doesn't stop that growing cost over time. So we still don't see how the Mars 1 plan, as stated, becomes sustainable over time. So the question is, how willing are you to change the scope of your mission, to de-scope it from one-way missions to maybe something that's like an orbital mission or something like that, given the real-world constraints and difficulties of cost, schedule, scope?
I would first like to comment on bashing NASA. I fully agree. As Barry has already pointed out, it's only possible to even consider going to Mars because of all the great things that NASA has already done. So let's not forget that. But our delays are not caused by technical limitations. They're caused by funding limitations. There is no reason why we could not have those technical reports if we had adequate funding. And, well, funding is difficult. And when you start your own company, you start to raise money, you will find that funding is always difficult and will always be difficult. So the answer is to your other question about sustainability of increasing crew size. I do think we talked about that. It's producing things locally. So we will need to develop the systems to produce things locally. And at first, simple things. Actually, we do already, of course, like water, nitrogen is already part of our plan to produce locally from the start, oxygen, and we will need to build on that capability of producing things locally over time. And if our first crew is scheduled to go in 2026, landing in 2027. The second crew landing in 2030, because then the 26 years actually goes over the December. 2030 is a long time away. If you look at what 3D printing has achieved in that amount of time, you can see where things are going. So the question is, can we produce on Mars a ink for your 3D printer? And I think that's much more an energy question than a technology development question. I mean, we can produce plastics already for 3D printers here on Earth. I am convinced that a lot of that is now done from oil, so it's breaking it down, but there's no reason why you couldn't do it the other way around.